out like that. So in this case, what is the correct way? What is the correct way? The correct way is this. Find the slope of the tangent line here, and find the equation of the tangent line over here. Maybe over here. And then, so at this point, we will call this guy A. So we can call this guy right here, A comma f of A. So we can call this A comma f of A. And then the other point, why don't we call this guy C comma f of C? Some of you call this guy A comma B. So I would like to just leave the letter B open. And so let me now call that point C comma f of C. So it's C comma f of C. So this point right here, I can call this guy C comma f of C. So C comma f of C. Say like that. And then if you call this guy C comma f of C, you know what? How about this? I think this is very confusing. Let me just erase this. Let me just erase the whole thing again. Let me just erase this whole thing. So this is a lot of mistakes. So what I'm going to do is I'm going to save this. And then what I'm going to do is I'm going to erase this. I'm going to erase all this here. And so now what I'm going to do is I'm going to do this the correct way. What should happen in this case is this. Is over here. So we find the tangent line to this point. This is an A comma f of A. So this one is what A comma f of A. And then this point we call it we call it for C. C comma. This is now C comma G of C. And then find tangent line here and find tangent line here. So basically we have to do this. Find tangent lines. So find tangent to y equals f of x at A comma f of A. A comma f of A. And this will be line 1. Now, we also do what? We also find tangent to y equals g of x at c comma f of g comma f of c, g of c. And this we can call this guy line 2. Then equate the two lines. Find A and C. All right, this is how you do it. So the key point is this. The tangent line to the curve y equals fx, we have to let this tangent point be A comma f of A. And then the tangent line to the curve y equals g of x, we have to call that point C comma g of C, or B comma g of B, but will be another point. Cannot call this guy A. If you call this guy x and that guy x, then of course that will mess up the whole thing. So here is my recommendation here. When you have an equation with a tangent line, this tangent point, do not call this guy x comma f of x. That is a no-no. You are not sure what you're getting into. Also, when you have to find the slope here, and this guy right here, this guy should not have any x. If it has any x in there, that will be wrong. Because this guy right here, how about this right here? The question is this one. This is not a line anymore. This is not a line. This is not a line. This is not a line. If this is not a line equation, this is what? This is not a tangent line. Because it is not a line. If it's not a line, how can it be a tangent line? It cannot be a tangent line because it's not even a line. And the problem is because the slope has an x in there. So the tangent point should never be called this by x comma f x. And never, when you plug in a slope right here, this guy right here should never contain an x. All right, I think that is good enough. Any questions on this here? Because many of you made mistakes on this, and also many good students who are top students in this class who are getting A's. By the way, there are many of you who are getting A's right now who have made this kind of mistake. any mistake on tangent line. Here the lesson is, if you have any question involving a tangent line, that do not let that tangent point be called x comma fx. And that is a no-no. Just a recipe for mistakes. Recipe for systematic mistakes. And then whatever you get, you get a junky solution. Any questions here? So let me write down the conclusion here. Tangent point should never be called, never be named x comma fx. Although sometimes works, this is a recipe for mistakes. Okay? Should never be named x comma fx unless you know what you're getting into. So sometimes it works, but a lot of times it doesn't work. So never be called a comma fx, x comma fx. Okay? Never. All right, any questions here? Is there any questions? Anybody has any questions here? Okay, I realize that a lot of the students in our class, they're not coming to this lecture. I think many of them took Calculus 2, and I'm not sure why they're taking Calculus 1 again. Maybe it's been a long time. But again, Calculus 2 techniques and theorems and formulas, no, not the techniques, but the formulas and theorems from Calculus 2 or higher is not accepted in this class. And certainly, L'Hopital's rule is one of the main rules because we're studying limits, that's why. And so the L'Hopital's rule is not allowed in this class. Okay? Throughout the entire class, until the final exam, L'Hopital's rule and other rules from Calculus 2 are not allowed, all right? Just want to make sure. I guess many of the students are probably not even here, so I don't know what to say, but anyway, okay? Any questions before we continue? Again, those of you who came in late, about slightly more than half of you I graded, but then slightly less than half, I think about almost 10 students. Exams are not graded yet, so don't be too sad. Hopefully, I am going to grade them today, okay? Oh, excuse me, just give me 1 minute, I'll be back. Okay, excuse me, I'm back here. Okay, does anybody have any questions on the test? Anybody has any questions on the test? Again,
I came in late. Did you go over number 7?
Number 7? No, I didn't. I did not go over number 7. So number 7 is a little bit tricky. Yes, it's a little bit tricky. Yes. What? Okay, so let me see. Save here, and then clear this. And so let me see. What did I write on number 7? So here's the answer key. The answer key is, let me see. Where is my answer key? Is it Math 4, and then midterm 2 is right here. And let's see, what did I write? By the way, this answer key just have answers, okay? It does not have, here is the, right here. Here is the answer. So, Yeah, it's a little bit messy. By the way, this part, this number 7 is the calculation is a little bit messy. It is a little bit messy, but it's not really that messy as many of you wrote. So I think many of you wrote like almost whole page of this. But the answer to the second derivative part B can be written about half page. But I didn't do this because I had to do the general cases with all these V's and the W's. Your specific cases, they look much simpler. So I have decided to just give you the answer here, but not to write a solution for the general case. Because again, all of you have different values of W and V here. So what I can do is I could actually do that. Okay, so maybe I will just do one case for a specific case of V and W. So do you want me to do that? So that will take some time here. I'm a little bit afraid, but okay, let's do it. Whiteboard, so let's look at it. So how about example 7? So problem number 7, example. And so what I'll do is, how about if we choose a value? So what value for V and W would you like to pick here? So the equation is what? The equation is sine of this V plus 2, and then X, and then plus Y. If plus Y is equal to what? Is equal to Y, and then what? Plus W. So that was the equation, right? And then we have to find the first derivative and the second derivative. So in this case, how about if I just pick the value for Y and W? How about if I say, I don't know, just pick one. Okay, let V equals what? Okay,
could you do 7 for V?
7?
7 for V and 1 for W.
You want 7 for V? Okay, so let's see. So you want this V to be 7? Okay, so we want the sine of 8x and the plus, and then for W you want what?
1.
1 for W, I see. Okay, so we want this. You want this, right? Okay. So.
Oh wait, could you do a sine of 9x plus y? Sorry.
Sine of 9x plus y. Okay, sine of 9x. So sine of 9x. I see. You said V equals 7. I see. I get it. My mistake. Okay, so basically we're saying that we have V is 7 and W is 1. Okay, so let's look at this. So first of all, so basically we are not. This is a general case. So what we will do is we will do this example right here. So this will be our problem. Okay. Okay. So now let's take the derivative here. Take the derivative. So we apply. Take what differentiate with respect to diff with respect to x. Differentiate both sides. That is differentiate both sides with respect to x. So if we differentiate both sides with respect to x, then what do we get? Then we get this. Then we get sine of. We get what? We get. So we get this cosine of 9x, and then plus y, and then times what we get. We get 9, and then plus. How about if I just put y prime? Okay, I don't use prime notation here, but I'm trying to make things a little bit simple. So the chain rule, if you apply it, we get 9 plus y prime, and that will equal y prime, which will be dy dx. If you write in Leibniz notation, and so that's dy of dx. I'm just going to write as y prime, and the plus the derivative of 1 is 0, so we get this. So now the next step is now this to collect all the x's, to call the y's and separate the y primes. So what we do get is we get cosine of 9x and then plus y, and then times 9. If we multiply by 9 there, we can put the 9 in front of it. So it's 9 times this, and then what that is now this is equal to, and then the right hand side we are going to collect the y primes. So y prime, this is going to be y prime, and then it's going to be y prime 1 minus, and then we will have a cosine of 9x, and then plus y. So we get this right here. And so now from here, now we get this. So from here, we get this here. And so now what is y prime? Y prime is now going to be a fraction. So I'll have to what, right? This is a fraction. So y prime is going to be, what is going to be this? 9 times cosine of 9x and then plus 1 plus y. And then over, and then this will be 1 minus, and then we have cosine of 9x and then plus y. And then this is what we get for y prime. Any questions here?
Man, Allison just really good podcast. I gotta send it to you.
We get this. So this is now y prime, which is dy dx. Okay, so now get this. And of course, some of you have the terms in the bottom. Instead of 1 minus cosine of 9 plus y,
Really
you have
good.
cosine of 9x plus
Okay,
y,
I need
then
to go
minus
poo.
1. If you do that, then there should be a minus on top.
He's cute.
So whether you write it this way or the other way, okay? So with a minus on top.
Do you want your laptop?
Bottom is switched.
Yeah.
With a
Take
different
it
sign.
before
That's
the
okay
first
too.
two
So now
drops.
what we do is now we move on here. So now what you do? Differentiate again. Differentiate again with respect to x. So if we do that, then what we get is now we get this. We get make the side on this side. We have more space here. So from here, what we do get is we get now y double prime. So y double prime is equal to now. What are we going to get? Well, we have to apply. Well, we have to apply this. Oops. So we get this right here. So the denominator is going to be now this. 1 minus, so what? 1 minus cosine of 9x, and then what? Plus y. And then it's going to be this square. So let me put this in parentheses. And it's going to be this square. And then now what is the numerator going to be? The numerator is going to be now this. And by the way, what we'll do is I'm going to factor the 9 separately. So what I'm going to do is I'm going to put the 9 here. So the 9 is out of the quotient. So I'm just going to write the 9 here. Write the 9 like this. And again, 9 will not be out of the quotient. I just pulled out the 9 separately. Okay? So I'm going to put it right there. So this is now going to be the derivative of cosine of 9 plus y. So what will that be? And that will be what? That will be derivative of cosine is minus sign, so therefore we get minus sine of 9x then plus y. And then now times the derivative of 9x plus y, which is 9 plus y prime.